Response of electrical circuit for different types of inputs. Under this, we have to discuss what is that step input. Okay, for step input, what is the response of electrical circuits? By taking one problem, numerical problem, we can understand the uh, response of electrical circuit. Then let us consider as RC circuit. So this is called series RC circuit. Consider series RC circuit, and this input is called step input. Here, for example, so V of T is called our input. Okay, I of T is called current, and then RC circuit. This is called R and C. When we know relation, so according to the KVL, V of T is equal to R into I of T plus 1 by C into integration of I of T into dt. Apply Laplace transform on both sides. So V of T become V of S and I of T become I of S. R into I of S and 1 by C into I of S by S plus Q into Q of 0 minus by S. That is called initial conditions. Okay. Initially, if the capacitor is having some charge, that can be represented like this. Q of 0 minus dr by S. Then V of S is equal to R into I of S plus I of S by SC, and Vc of Q by C is called V, voltage. V is equal to Q by C, that is equal to Vc of 0 minus dr by S. Okay. Now all initial conditions set equal to 0, that is nothing but Vc of 0 minus is equal to 0. This is called initial conditions. Voltage across the capacitor initially 0. That is nothing but Vc of 0 minus is equal to 0. So the equation will become, this term will become 0. And this equation V of C is equal, V of S is equal R into I of S plus I of S by SC. Then V of S is equal to I of S. Take common and then R plus 1 by SC. Then this is the current, this is the called voltage across V of S equation. Okay. Then I of S, voltage across the capacitor V of S. So source voltage V of S is equal to, okay, I of S into R plus 1 by SC. And then this is the series RL circuit, series RC. Now coming to the series RL circuit. So in this also same applying KVL as same as before RC. V of T is equal to R into I of T plus L into di of T. This is called voltage across the inductor. L into di of T. So by applying Laplace transform on both sides, V of T will become V of S and R into I of T will become I of S. R into I of S plus L into. So S into Laplace transform of differentiation is nothing but S into I of S. So initial conditions present. That's why minus I of 0 minus. If it is all initial conditions are equal to 0, if it is initial condition 0, this term will become 0. That is equal to I of 0 minus is equal to 0. That means before the inductor is having some current before connecting to the circuit. It's having some initial conditions. Okay. So before connecting to the circuit, inductor is having some current. Okay. So that is called I of 0 minus is equal to 0 ohms. So initial conditions, if initial conditions equal to 0, then equation will become V of S is equal to I of S. Take common and then R into SL. Then I of S is equal to V of S by R plus L. By taking the common L, V of S by S plus RL. So this is about the theory some regarding series RL and RC circuit. This can be understood by using MATLAB symboling. First, so we have to discuss by using one problem. So this can be understood by using one problem. To simulate and study the transient response of series RC circuit using MATLAB, where R is equal to 200 ohms, C is equal to 10 microfarad. Following condition. Following conditions means these are the two conditions. Source voltage 40 volts DC with initial conditions set to equal to 0. Source voltage 40 volts DC, like this is called step input. The amplitude is nothing but 40 volts. Okay, step input with amplitude is called 40 volts. That is called DC source voltage. Source voltage 40 DC with initial conditions set to equal to 0. And the next second condition is called source voltage is a pulse signal. Okay, with a period of 0 seconds with pulse width is called 5 milliseconds and rise and fall time is called 1 microsecond. Amplitude is 20. Amplitude is 20 volts and time period is called 5 milliseconds. Width of the pulse is called 5 milliseconds. This type of input can be generated by using step input. Okay. So 5 milliseconds, the pulse width must be 5 milliseconds. That means by taking the step input with the amplitude is called 20. Okay. And so we will get first 20 into u of t. That is called like a DC source. Then from this, after 5 milliseconds, we have to subtract. Okay, that is called u of t minus 5. U of t minus 5. 20 into u of t minus 5 milliseconds. Okay, so that we have to subtract. Then we will get pulse width 5 milliseconds. Okay, then here first we understand the first case one. V of t is equal to 40 into u of t. This is our step input. U of t is called step input, DC. Okay. For t is equal to 0, 1, t is equal to 1, 1, t is equal to 1 only. 1 into 40, 40. Okay. U of t always 1 for t greater than or equal to 0. That's why V of t is equal to 40 volts, DC voltage. Apply Laplace transform on both sides. That V of t will become V of s, and Laplace transform of u of t step. Laplace transform of the step input is nothing but 1 by s. V of s is equal to 40 by s. Then we know relation I of s is equal to sc divided by rc into s plus 1 by rc. Okay. Into 40 divided by s. Okay. And then simplify 40 divided by r, 1 divided by s plus 1 by rc. From RC circuit. So already the derivation is over in RC circuit. I of s is equal to, for the RC circuit, I of s is equal to V of s by 1 by V of s by r plus 1 by sc. So substitute, by substituting here, we will get to this expression. Sc divided by rc, s plus 1 by rc into V of s. So 40 divided by r into 1 by s plus 1 by rc. And then apply inverse Laplace transform of the above equation, we will get I of s will become I of t, and then 40 by r, and then inverse Laplace transform of 1 by s plus 1 by rc is nothing but e power minus 1 by rc into t. Substitute these values of r and c in this equation, and then r is equal to 200 ohms and c is equal to 10 microfarads. We get I of t is equal to 40 divided by 200 into e power minus 500 into t. So that is nothing but by at t is equal to 0, I of t is equal to e power 0, 1. That's why 40 by 200, that is called 200 milliamps. 200 milliamps, this means 0.2 amps. Okay, by using MATLAB, we have to verify this current. Okay, I of t for t is equal to 0, it will start from 0.2 amps onwards. 200 milliamps is nothing but 0.2. 0.2 onwards, it will start and ends at t is equal to infinity. Infinity is nothing but 5 time constant. Steady state time, final time is called nothing but 5 time constant. At under the infinity condition, the current it will become I of t is equal to 0. Exponential is increasing. Exponential is increasing like this. E power minus 500 into, so exponential is increasing. Then time constant, time constant RC at 2 milliseconds. So at 2 milliseconds, the current I of t is nothing but 200 into 37. For exponential is decreasing, time constant is nothing but 37% of the final steady state value. So 37% into 200. 200 is called final steady state. 200 into 37% is nothing but 74 milliamps. Okay, this is called current I of t at time constant 2 milliseconds. Then voltage drop across the resistor R is nothing but VR of t is equal to R into I of t. We know current resistors from the given data, from the data resistance known, and I of t already we known. So for find substitute this called VR of t is equal to R is called 200 and I of t is nothing but 400 by 200 into e power minus 500 into t. Then 40 into e power minus 500 into t. So this is called voltage across the resistor VR of t, and at t is equal to 0, substitute here e power 0, 1, and then 40 into 1, this is called 40 volts. At t is equal to infinity, VR of t is equal to 0. At t is equal to infinity, substitute t is equal to infinity, and then voltage will become VR of t is equal to 0. So this is called exponential is increasing. VR of t is exponentially increasing, and I of t is exponential is decreasing. Okay, voltage across the resistor is exponential is increasing. Okay, like this. So the plot I of t versus time, VR of t versus time as follows like this. I of t is exponential is decreasing in this way. So it start from 200 milliamps and decreasing in this way. And the time constant is called, at time constant is nothing but 37% of final steady state value, that is called 37% into 200 is nothing but 74 milliamps. Okay, at time constant. And then next voltage across the resistor VR of t is called exponential is decreasing in this way. First voltage across the resistor VR of t at t is equal to 0, VR of t is equal to 40. So this is 40, and at time increases, VR of t is equal to decreasing like this. Okay, in this way, voltage decreases and also current is also changes in this way. Understood? So next, this is called RC circuit. Okay, then voltage drop across the capacitor C is voltage across the capacitor C is nothing but supply voltage minus voltage drop across the resistor. In RC circuit, what is the voltage across this? Voltage across this VC of t is nothing but V of t minus VR of t. This source voltage minus voltage across the resistor is nothing but voltage across the capacitor. Voltage across the capacitor is nothing but source voltage minus voltage across the resistor. This drop is nothing but VC of t. So that's why, so we will get this expression. Here VC of t is equal to V of t minus VR of t. That is equal to. So V of t is 40 into e power minus 500 into t, and the VR of t is nothing but, we will get like this expression. VC of t, V of t is called 40, source voltage is called 40, and we know VR of t is equal to, what is the expression? 40 into e power minus 500 into t, by taking the 40 common. Okay, then it will get 40 into 1 minus e power minus 500. Then VC of t, substitute at t is equal to 0 in this equation. E power 0, 1 minus 1, 0, then voltage across the capacitor at t is equal to 0 is equal to 0. And then at t is equal to infinity, this will become 0, and this term e power minus 500 into t will become 0, and only 40% at t is equal to infinity, then we see of t at t is equal to infinity is called 40 volts. That is nothing but at t is equal to 0, 0, at t is equal to infinity, maximum voltage. So 40 volts. So like this, we can understand the response of electrical circuit, that is called RC circuit. This can be understood by using MATLAB simulink. Okay, first go to MATLAB, open MATLAB, and press simulink, and then new window. So open like this. Okay, and then first, what is our input is called series RLC. First, we have to concentrating on series RLC circuit. Take a series RLC branch. Right here, series RLC branch. Series RLC branch. Don't take series RLC load. Series RLC branch, and it can easily converted into resistor and like this. Resistor series RC. Na? So change this also to capacitance step. See. Apply. Okay. This is called series RC. Control R and rotate. This is a RC circuit, and our input voltage is called, what is that input voltage? 40 into here. What is the input voltage? V of t is equal to 40 into V of t. This is our input voltage. This is our input voltage, 40 into V of t. Am I right? 40 into V of t. That's why this is called, V of t is called step input. Okay, step input. And then here we have to take one to connect the step input. One controlled voltage source is required. Controlled voltage source. Controlled voltage source. Like this. So connect this controlled voltage source here, and another terminal to the RC circuit, and the next like this way. Okay, this is called controlled voltage source. And the next take one step input. Step input. Step. Place here. This is called step input. And here, what is the input? 40, 40 into V of t. That's why open step input, it start from 0 onwards. Step time is called 0 and initial value 0, final value 1. Apply OK, and then here amplitude is called, what is the amplitude of DC voltage? 40. That's why take one gain right here, gain, and place here gain, multiply into 40, and then this is called our step input, and here change to like 40, change 40, and then apply OK. So this is our input. Okay, and next take one ground, connect here, ground, place here. So like this is your ground. And what is the resistance here? According to our problem, resistance is called 200, capacitance is called 10 microfarad. Resistance is called change like this, 200 ohms. So resistance is called 200 ohms. Apply OK. And then capacitance, how much capacitance? 10 microfarad. Change like this, 10 microfarad. Okay, 10 microfarads, apply OK. So if you want to measure the voltage, input voltage and then output voltage, take one voltage measurement. Okay, voltage measurement, place here. And then also you want to measure what is the waveform. Take one scope to identify the what is the waveform, what is the response across the capacitors T. See, connect like this. This is called voltage across the capacitor. And next here, take one more voltage source, connect here. This is called one more voltage across the resistor. Across the resistor, this is the voltage. And next, and also one input voltage. What is the input voltage? You want to find the input voltage, connect one voltage measurement, connect inputs. Okay. And also, if you want to find the what is that current in I of t, that is called take current measurement, and place here. Okay, and connect here like this. This is called current measurement. So input voltage and voltage across the resistor, and what is this? Voltage across the capacitor. Okay, first input voltage. So 3 ports are required in the scope, open scope, and the number of input ports is nothing but here number of input ports is equal to 3. Apply, and then OK, close. So this is called number of input ports. Okay, the number of input ports is equal like first connect input port to, this is called first port is called input. Okay, and the second one is called voltage across the resistor. Then third one, voltage across the capacitor, and also one more port is required. That's why go to change into four ports. Apply OK, and then here first one is called voltage, input voltage. Second one is called voltage across the resistor. Third one is called voltage across the capacitor. Okay, next the final one is this is called current in the series circuit, current in the circuit. Like this circuit connection is over. And then what is the here time constant is called here time current is called 200 milliamps, and time constant is called 2 milliseconds. Okay, and time constant is equal to 2 milliseconds. And then what is the first we have to verify the current I of t and VR of t, voltage across the resistor, current in the series circuit, current in the circuit exponentially decreasing, 200 milliamps to is decreasing like this, and VR of t is decreasing from 40 onwards, and capacitor voltage increases up to 40. Okay, so then Here, right here, for example, 0.1, 10. Okay, simulate. And then take one power guy. Okay, take power guy right here, power guy, place here, and simulate again. Okay, like this we will get the response. That's true. So this is our circuit simulation. Then go to scope, open scope, and change how many ports here? 4. Change layout to 4 ports. First one is called input. Second one is called voltage across the resistor. And third one is called voltage across the capacitor. And final is called current, 200 milliamps. Okay. And then open this scope and maximize and change the layout to like this background color, figure color, white, axis color, white, this is color, black, and active display 1, and then voltage measurement and thickness, change the thickness, and color is color red. Then apply. Okay. Okay. And the change like this also. Just white color. And the next change layout. Active display 1, active display 2. Change color into like this. Thickness of this waveform. Color 2. Then apply. Okay. And next active display 3. Change the thickness of the color. And then next active display 4. Change this color of this. Yes. So this is called response. First one, what is the first one? In Simulink circuit, first one is called his is called input voltage. Input voltage is called 40 volts is source. Na? So verify 40 volts. So this is our input voltage 40 volts. Okay, 40 volts. For example, stop time 0.0. I'm changing the stop time to 0.03. If I'm changing like this, okay. The change stop time is equal to 0.02 and then simulate and then open. So in this way it can be. Here input voltage is called 40 and this is called second one is called what is the second one? Voltage across the what? Voltage across the resistor. Voltage across the resistor exponentially is decreasing. VR of t voltage is decreasing like this. Okay, voltage across the resistor is decreasing in this way. Like this, voltage across the resistor VR of t is decreasing from 40 volts onwards. In this way, is decreasing. This is the response. And next current is also decreasing from 200 milliamps. No? 200 milliamps. This is called 200 milliamps. That means 0.2 amps. From here, this is called 0.2 amps. 0.2 amps. Here onwards, this current is decreasing. Okay. And next, what is this voltage across the capacitor? Exponential is increasing now. Voltage across the capacitor is exponential is increasing. Oh, okay. So like this exponential is increasing. Okay. So that is called Exponential is increasing voltage across the capacitor up to 40 volts. Maximum voltage is called 40. Here, what is the voltage here? 40. Okay. This is the voltage across the capacitor, 40 volts. In this way, 40 volts, maximum voltage. And then what is the current here? Current 200 milliamps means 0.2. So like this. So this is the response of series RC circuit for step input. Okay. Response of series RC circuit for step input. If this is input, and then is exponential is decreasing, voltage across the resistor is decreasing from 40 onwards. Initial voltage is called 40, and then voltage across the capacitor increases up to 40, and then current is decreases exponentially from 0.2 amps onwards. That is called 200 milliamps means 0.2 milliamps. This is about series RL RC circuit. Series RC circuit. Next, coming to the another circuit. What is that? Next, another problem. Coming to the another problem. Another case. Case 2. Case 1 is called source voltage 40 volts DC with the initial conditions equal to 0. The next case 2. Source voltage is a pulse signal with a period of 0 seconds and the pulse width is called 5 milliseconds. 5 milliseconds means 0.05. Okay. 5 milliseconds, 0.05. With the rise and fall time, amplitude is called 20 volts. So the how to get amplitude is equal to amplitude 20. According to the problem, amplitude 20 and pulse width is called 5 milliseconds. Okay. Amplitude 20. This is called amplitude. This amplitude is called 20. Apply OK. And first, how to get 5 milliseconds means first we have to take the step input. From this, we have to subtract after 5 milliseconds. Okay. So, because of that, so we have to take one subtract. So, subtract means how to subtract this like this. U of t, second case 2. So, V of t, this is called 20 into V of t. That is called step input. From this, we have to subtract 20 into V of t minus 1. Okay. 20 into V of t minus 1. And the pulse width is called 5 milliseconds. 20 into V of t and 20 into V of t minus 1. The pulse width is only 5 milliseconds. That means instead of 1, right here 0.05. Okay. After 5 milliseconds, the pulse width will become 0. And here, right here, 0, and take one more place here. And right here, step term is called 0.05. Step term is called 0.05. And then apply OK. And take one subtract. Place here. Connect this here and the next here. So this is called 20 into V of t. 20 into V of t minus V of t minus 1. T minus 1 is nothing but pulse width is called 0.5. That is called 0.05 onwards it will start. Okay. And then simulate. Then what is the input? For example, so first one is called our input now, and simulate and open. Let's wait. Here change the stop time is called 0.1. Change stop time 0.1. Okay, and then simulate again, and then open scope. So from 0.05 onwards, this will become 0. This is called U of t minus U of t minus. So pulse width is called 0 to 0.05. Here pulse width is called 0 to 0.05. Okay, 0.05 here pulse width. Pulse width according to our problem What is the pulse width? Pulse width is equal to 0.5 milliseconds. That is nothing but 0.05, and amplitude is called 20. Okay, and amplitude is equal to 20. Here 20. And then next here from 40 into u of t for second case 2. Case 2, where is the case 2? V of t is equal to 20 into u of t minus u of t minus 1. Okay. Pulse width, to get pulse width 5 milliseconds, we have to use the like this. And V of s is equal to apply Laplace transform 20 divided by s into 1 minus e power minus s. And then I of s is equal to substitute this V of s in this previous expression. Already solution is there now. I of s is equal to, for series RC circuit. Series RC circuit, V of s is equal to I of s into R plus 1 by s. Substitute in this equation V of s. V of s is equal to, what is that expression for case 2? Case 2, V of s is equal to 20 by s into 1 minus e power minus s. And then I of s is equal to 20 into s into c, 1 minus e power minus s divided by s into rc into 1 plus s plus 1 by rc. Simplify. And you will get apply inverse Laplace transform, and taking inverse Laplace transform both sides, so we will get I of t expression 20 by r e power minus 1 by rc into t u of t minus e power minus 1 by rc into e power t minus 1 into u of t minus 1. So substitute values of r is equal to 200 ohms and c is equal to 10 microfarad. So we will get expression like this. I of t is equal to 20 divided by 200 into e power minus 500 into u of t minus e power minus 500 into t of minus 1 to u of t minus 1. Okay, in this way we will get the response I of t. And then at time t is equal to 0, what is the voltage, what is the current? I of t is equal to 20 divided by 200, that is called 100 milliamps, nothing but 0.1. So the current, like that is nothing but the current here. The current start from what value? 0.1 amps. Is exponentially is decreasing. At t is equal to infinity, I of t is equal to 0 means at t is equal to infinity condition, the current is equal to 0. At starting condition, the current is called 0.1 amps. So from 0.1 onwards to it is decreasing. So like this fashion. Here 0.1 and then decreases in this way. Exponential is decreasing and the current is equal to 0 at t is equal to infinity. Infinity means under pi time constant. Okay. So like this exponential is decreasing. Initially the current is called 0.1. The current is decreases. Okay. And that t is equal to 0, infinity, at t is infinity, at t is equal to infinity, I of t is equal to 0. Then voltage drop across the resistor R is nothing but VR of t is equal to R into I of t, and then 200 into 20 divided by, substitute this 200 into 20 divided by 200 into this multiplication, as we will get like this expression. Substitute here t is equal to 0 and then VR of t is equal to 20 volts. T is equal to 0, substitute in this equation, and you get at t is equal to 0, VR of t is equal to 20 volts. T is equal to infinity, VR of t is equal to 0. That means exponentially is decreasing from 20 volts onwards. From 20 volts onwards, exponential is decreasing, and that's expression can understand here. From 20 volts. So what is that voltage across the resistor? No? Voltage across the resistor, that is called second port. Voltage across the resistor, that is nothing but second one. Okay, voltage across the resistor. Here 20 volts. Here 20 volts. Second one is called 20 volts. From 20 voltage onwards, it is decreasing. At t is equal to infinity, at nothing but at steady state time, this current voltage drop is equal to 0. At t is equal to 20. Like this, voltage is changing. 20 to decreasing, exponential decreasing. Then next, what is the voltage across the capacitor? Vc of t. Vc of t is exponential is increasing. Okay, exponential is increasing. At t is equal to 0, Vc of t is equal to 0. At t is equal to infinity, then where is that voltage across the capacitor? Capacitor is nothing but third port. So open third port. What is the third one? So at t is equal to 0, capacitor voltage is equal to 0. At t is equal to infinity, that is called steady state time, the capacitor voltage is increases to like this, increasing, exponential is increasing. Okay, exponential is increasing. At t is equal to infinity, here 20 volts. This is a mistake, some mistake is there. At t is equal to infinity, Vc of t is equal to 20 volts here. Okay, at t is equal to 0, Vc of t is equal to 0, t is equal to infinity, Vc of t is equal to 20 volts. Okay, And then at t is equal to 5 milliseconds, at time constant is called 5 milliseconds. So we see of t is equal to 18.36. We will get like this. Okay, 5 milliseconds means here approximately is equal to 20 volts. So in this way, if you have to simulate the response of series RC circuit by taking this example, we can understand the step response. Okay, so this is about response of series RC circuit.